Hey, Susan again. Here's the short video of the topic here. Maybe we're going to continue next week. And what happened if I have RC or RL circuit, but my source is not constant? It is not DC value. Well, how I can deal with that situations? My case. So basically, here's the details. You can find it in your textbook. But generally speaking, when you are dealing with the Y of T is constant DC value, we find out our final response or forced response, it will be a constant as well. And in the RC, we find V open circuit, and in the RL, we find I short circuit. So it is the same behavior of the input source. Input source constant, the forced response constant as well. The same concept here if I have different source. So if I have constant here, forced response will be match the same your input signal. If I have exponential source, my output or my output forced response will be matched with that one. The only thing is different at the time, but the exponential term will be the same. And similarly, if I have a sine wave or cosine wave, the only thing you have to consider it, you have to include sine and cosine both, because in the differential equations, sometimes we end up with the sine and cosine at the same time. So that's the general form. So today we're gonna just solve an example regarding for the exponential source. And here are the general procedures, how we can solve it. As we start from the constant source, we have to collect all the inductors and capacitors and put just single capacitor and single inductors. And we dealing with the steady state, find the R totals, which is based on the time constant, and then we plug the general response, forced and natural response to find out. So here is we're gonna focus about the forced response since we have a different source than constant source. Let's see how we implement this example here and how we solve it our circuit when we have our source here, Vs here, and it is exponential part with U of t. So basically U of t in that case here is mentioned about just include the positive time. So my Vs, it's larger than or equal 0. It has that concept. Another thing, at the t equal infinity, this one will be vanished. So this will be 0. And let's see what we have. We have the 10 volts here, and we have the switch open at a certain time at t equals 0, and we have 5 and inductors with the 4 and Vs case. So the first starting point, we are trying to find the Vf, the If here in the inductor. So I'm talking about the If. Since my If, it should be is the same as V output. Even my V output here is the volt, and here I'm talking about the current. Still, my forced response would be follow that direction. So basically, we can assume any constant. That one is times the same exponential part or attenuations term, 2t. Okay, 2t. That's our forced response. So just to make it easy, I will find di by dt. We need it later. So in this case, here is the minus 2 times b e is minus t times b e is minus 2t. Okay. Now let's see is our focus about the after the switch is open. So what we end up, so this is our circuit here, which will be basically our inductors and our 4 amps and our Vs. Here is our I of t. And here is the plus, here is the minus, and here is the 4 amps. So my current go this way. So let's apply the Kirchhoff voltage law. In that case, I want to go start from here. Here is the Vs. So Vs, here is the minus to positive, means minus Vs plus, here is the current times 4 amps R times I of t. And here's the plus the current through the inductors, which is basically L di by dt. And this is the summations will be equal 0. Rearrange our equations here and put the numerical value. Here's I'll end up with the L is equal 1. Okay, so the di by dt is L equal 1 plus R equal 4 I of t equal Vs of t. So this is our equations 1. So basically what do we have? We just Vs or our source here, we can assume it as our current source. Our current source in that case. So basically what do we have? We have our source, it is Vs10. This one is 10 ES minus 2t. And here's we're gonna just we're talking about the first response. So we're talking about the IF. So just first derivative 2b. Here is the 2b or minus 2b ES minus 2t plus 4 times I will be 4b ES minus t. And if you take it, here is gonna be 2 and 4 will be 2b ES minus 2t equal 10 ES minus 2t. From here, we end up with the b equal 5. Here is the b will be 5. So another meanings, IF equal 5 ES minus 2t. So now I find my IF. Again, guys, we are looking for the I of t will be IF plus IN of t. That's our one. So we already find one. So now we try to find the second one. Oh, I have to add another slides. So there's another one that we can find. We are talking about the now natural response. We are looking for the IN, how we can find IN in that case. So again, guys, don't consider that time. I'm talking about the general source right now, not the constant source. So in that case, IN is exponential part. So it's basically A ES minus T over tau. Now, what is the tau? The tau is the circuit after closed circuit, or the before the after switch to close. So basically, that's our circuit. Again, it's the same circuit that we have. That's the circuit, and here is the 4. And our time, it's basically L divided by R, which R in this time here is you have 1 divided by R, it's 4, it is 0.25. Okay, so we're done with that part. So now how we can find our natural response based in these equations here, I of t. So we have the tau, and we can generalize our I of t, which basically IF plus IN. So here is the A ES minus. Here is the 0.24, so it's 40 plus 5 or 5 ES minus 2t. This one is IN. This one is the IF. That's two components. So we are looking to find the IA in that case. How we can find IA? We need to find our I0, generally speaking, talking about the current. Okay. The current now, what we can find it, how we can find it? We find it based in the second part when I have the switch before destination conditions. Okay. How the circuit looks like, it has 10 volt, it has a 5 ohm, and conductors will be short circuit, and we have here is the 4 ohm, and here is the VS. This is our circuit right now, or before t equals 0. And here is the 10 volt, and here is the 5. And here is the current that we are looking for, the I of 0. Where's the I of 0? That's the total current, not the natural response. I mean, itself comes from the total current here. Again, this one short circuit. So basically, the current will be goes this way here. I can find IO from my circuit here will be based in 10 divided by 5 will be 2 amps. Now let's apply that in the previous one. Here is the questions number 2, and here is the number 3. And I will use 2 and 3. I will find out here is the 2 amps. I applied at t equals 0, so that means A plus 5. So you end up with the A will be minus 3. So now we can implement our general equations by the I of t will be minus 3, E is minus 40 plus 5 E is minus 2t, sorry, not 40. 2t. That's the general response. Again, you see the forces. This is the force response. Now the natural response exponential based on the tau, but this one's depend about my input source. The same thing. Okay, so done for this video, guys. Thank you so much.